Hi, Vicki Williams here. I want to explain a little bit more about compounds breaking up into ions and how many ions they break up into. For example, if we look at the formula of sodium chloride, we see that there's no subscripts. That means there's just one sodium and one sodium ion and one chloride ion, and they break up into water into a sodium ion and a chloride ion, and there's only 2 ions in that solution. Now when we have calcium chloride, we have a subscript on the chloride, and that means there's 1 calcium, but there's 2 chloride ions. And so that actually breaks up into a calcium 2+ ion plus 2 chloride ions for a total of 3 ions. Let me show you that equation. You can see 1, 2, 3 ions. And the third compound I want to talk about is aluminum chloride, and aluminum chloride is AlCl3, so there's 3 chlorides for every 1 aluminum, and this breaks up into 4 ions, and I'll show you how that looks. And please don't worry that you don't know what kind of ions anything makes, because you don't know that yet. We're going to talk about that in a couple chapters. So there's the equation, and there's how aluminum chloride makes 4 ions. So in this experiment, experiment 14, I want you to notice the difference in the curves between the different substances. And what we're going to do in this experiment is I have a conductivity probe in a beaker, and I have a stir bar in the beaker, and let me stir that a little faster so you can see that. It's just a little bar magnet, and inside the hot plate stir apparatus, there's a magnet that spins. So what I'm going to be doing is I'm going to be taking 1 drop at a time of each solution. And so this first one we're going to do is sodium chloride. And as I add each drop, we'll get a new conductivity value. And we're going to see how the conductivity value changes by adding more drops. So first I'll put in 1 drop, then I'll put in a second drop and tell the computer it now has 2. Then a third drop until it has 3, and so on and so forth. But you don't need to watch me put in drops. What you need to do is watch the computer reading. So I'm not going to show you every time drop by drop, but you will get a graph with all of it on there, and we do change out the distilled water between each chemical, so that we're just measuring 1 chemical at a time. So the next chemical I'm testing is calcium chloride. I'm going to do it the same way by dropping 1 drop at a time, getting a 0 value before there's any drops, and then recording the curve we get, which scientists call it a curve whenever we have a graph, whether it's a straight line or an actual curve. That's just the way we do it. So this is the curve we got for sodium chloride, and now I'm going to press collect again, and I'm going to say store latest run because we want all of these, and then I'll start again. I'll collect keep with 0 drops, and then I'll start doing the drop by drop. And I'll stop the recording because you don't need to see every drop. Here's a picture of what the graph looks like with the calcium chloride on it too. And next thing I'm going to do is the aluminum chloride. Now I'm going to be doing our third chemical, aluminum chloride. And I'm going to store latest run so that we get all three of these on our graph. And I'm going to keep the 0 reading. And now I'm going to put in 1 drop. Press keep now that it's stabilized, and then I will show you the graph at the end. Here's the graph with all the data on it, and I will be putting some annotations on it and some lines on it and give you the final graph. That's the end of the experiment. Thank you very much.